Hey, greetings everyone. Mark Miller here. Fred's with me. Fred, say hi. Wave to everybody, please. Thanks, Fred. Rory's not here with us today. It's Friday. You just got me. I am streaming for the first time from a secondary machine. So, yeah, hello, hold on. Yeah, honey?
That's more interesting than it is.
Well, it's interesting in the sense that I'm really interested to know how the quality is on this. Because yeah, why don't you go online? Why don't you go check me out on, yeah, it's at twitch.tv/coderushed. Yeah. All right, good. Yeah, go find me out there and listen and see how the audio and visual quality is. Let's talk about what we're going to do today. And let's bring up some CodeRush music here. Hold on. Oh, it looks like my music is not. I love that. Isn't that great, Fred? We like that. Let me hit my button on my Stream Deck again. Music. It is not working. Come on, Stream Deck. All right. I got to come over here and type in command music, I think, if I recall correctly. Is that the command? But those moves. There we go. Music starting that way. I wonder if Stream Deck's going to recover or if I need to restart it. I wonder what's going on with that. All right, kids. Wow, if you were with us yesterday, pretty good show. We learned that the name tags across the bottom were sucking up a lot of GPU. Something like 20% of the GPU was used to draw the name tag. And why is that? Well, because we were doing a color shift on the name tags as we go across. So each one was shifting to a different color. There were 5 of them. We were doing it at, in some cases, up to about 40 frames a second. Should have been a little bit less, should have been 30. Hey, I look and sound good. According to Check Positive, we're trying to focus on code. Not as good as you, Check Positive, says Codebase Alpha. So, fair point. Check Positive says fair. Fair. So we learned that was the case, and we were able, by changing the background to something that we didn't shift the color on, we were able to get like 20% of our GPU back. And around that time, I realized I'm doing color shifting all over the place. We're doing it as a way of essentially conserving resources. Instead of having to have a blue zombie and a red zombie, I just have one zombie and I shift its color to blue or red wherever I want it to go. Same thing with the weapons. I do the color shifting, all of that. Let's see if we can demonstrate that. What was it? Let's see here. Let's shift.
Willie.
Let's go to Willie. Let's close the scroll. His color's red, so we should see red. And then let's go to Fred. Close the scroll. It should be blue. And it's not. And it did not go because of it. It's interesting. It didn't do that because I made a change to the code to test that. Then I undid the change. At least I thought I did. And apparently, no, I did not. Where is it? It's down in here. Shift color. Let's see, are we still calling it? We are. I had added code earlier that took this out. Not sure why. I'm going to refresh the drone. Or wait, that's the. Yeah, why is that the case? Why is it acting as if the old code is there? Now I don't even understand what's happening. Because I was like, wait a second. Interesting. I totally refreshed it. Let me try again here. Let's refresh these. Let's take the back overlay, which is the one we're working on right now. We'll refresh that. Let's initialize the player data.
Willie. Fred.
Nope. Okay. Well, now I'm pretty confused about that. Why would that not take this latest change? I wonder if I need to do, if it was because I undid it and I didn't save the date timestamp of the file. I wonder if there's something going on there. Let's save that and refresh one more time. Maybe it's a refresh issue. Okay, initialize player data, and
Willie.
that's what it was. It was a save date timestamp thing. I think because I had I did undo, I think maybe. I'm not sure how that impacted it, but at any rate, now this is working the way it used to. So the code that I had this morning was the stuff you saw before. So I'm doing color shifting all over the place there. So when Lady comes up, I think her color, well, like my color is purple. So when this goes down, you see purple, and little Cutie's color is blue. You see the blue. It's the same resource, but it looks different each time because of the color shifting. And we really didn't get a sense that we were having a problem with color shifting until the nameplates. And I think what was going on is the nameplates were sucking up more GPU because they could. They were able to draw relatively quickly, and so they finished their frame. Their request animation frame came in and requested another animation frame and said, okay, go ahead and draw yourself. And as a result, they were taking up more time, I think, because of that. I don't know. I don't know entirely. I don't have a strong sense of it, but I do know that a big chunk was freed up when we changed the color shifting. We got rid of that. Yeah. Now, one of the things I read about that I kind of want to implement is drawing onto a background canvas. For things that don't change, like in this display here in the front overlay, we've got all these name tags. They're not changing right now, right? And you've got the clock, which is not really changing, the background of the clock, not really changing. So all of that could be drawn on a background canvas and then updated only when a change occurs, such as we enter combat, like that. Or when a player takes damage, for example. Like, let's go in here. Got two different music things going right now. Let's turn off the Dungeons and Dragons music. All right, there we go. For example, when a player takes damage, so let's do that. Give me 22 damage. That. And so it updates, and that's when we want to update the background canvas. So we're not always drawing it every frame. Instead, we're drawing it only when it changes. So I want to do that. But I want to be able to get a strong sense of what kind of progress are we making.
Fred.
That's what I want to do. Let's exit combat. So to do that, I need some sort of way of visualizing my frame rate. Visualizing the frame rate for each of the three layers. Oh, and we got music coming in again. Put the exit in combat. Let's turn that off. There we go. It's interesting. One of my stream decks is seemingly working. It's seemingly working. Alright, let's do this. I'm going to refresh these too. So I want to visualize is what I want to do. And I want to visualize the frame rate. And once I can visualize the frame rate, then I want to start being able to play with things. Like I want to be able to turn on or off hue shifting in kind of a global level and see what's going on. You can see, you can see a real good example of this. Like if I do test all damage, watch the performance of this. That's not bad, but that is the dice layer. That's using the old code. Let me refresh it. And I'm sorry, that's using the commented out code where no color shifting is taking place. And you can tell because if you look at like, for example, the zombie heads, they're all exactly the same color. If you look at the knives, the blades going around the dice, spinning around the dice, those are all red. There's no color shifting going on here yet. Let me clear those. And even all the explosions are the same color. Now, if we refresh the cache here, it should reload. Let's initialize again.
Bushwhacker. Red.
And let's run that same dice check again. And now we should see color shifting, and the performance should be roughly. Let's clear the dice. One more time just so you kind of get a sense of it. It's slower. The frame rate is lower. So I wanted to understand what that frame rate is. That's what I want to do. So we got to calculate that. And I want to visualize it. I don't just want to put the number out. I'm a little bit worried about the number. Stream is stuttering as well. Yeah, so that's interesting. Thanks for that. So the stream stutters when a lot of dice are out. Is that true? And did the stream stutter before when they were not, when that option was off? That's kind of the question that I have for you. And I think we'll kind of figure it out as we move forward. So I want to, yeah, okay. All right. Let me go in. I'm going to refresh the 3D dice layer right now, so it's not painting any of those guys down. I think I'm going to actually turn it off for a second here. Let me turn off the dice layer. I'm going to keep the drag in front overlay and the back overlay up. I'm going to hide the scroll. I'm keeping those overlays up. I've stopped the dice layer, and let's figure out how we're going to show what it's going to look like. I always bring up PowerPoint when I try to visualize, what the UI is going to look like. I have kind of a rough sense of it, but it's a little tricky because I want to visualize this on top of what we're already sending out. So, and I don't know, I'm kind of thinking, I've got this idea where we do something like, something that looks like this. And we throw some text here next to this right here. I'm going to say like something like 30 FPS, whatever that is there. And because frame rates are likely to radically change every frame, right? We're going to get, every time we calculate it, we're going to get a different number. But I also think it's kind of interesting to get a sense of what that disparity is like over the last, like say for example, 10 frames, right? So this will be over the last 10 frames what my average is, I think. I'll indicate it there. These will be my last 10 frames. And maybe we'll even do something where the further away in time it is, the smaller it is. Something like that. We'll kind of weight it visually like that. And so that's kind of a way of doing that, right? That's one way of visualizing one frame rate for one of the three pieces. We can also do something like this, where we are like drawing a graph over time. And in addition to drawing the graph, we could do things like this. Wait, that's not what I want. We could draw lines like this at times to indicate important events that we're changing and give those labels. For example, down here we might say something like turned off color shifting, like this. And over here we might say turned on the background canvas drawing, canvas drawing, painting, something like that. So this would be a way to really give it a great visualization. I like the graph, but then I like graphs. Yeah, well, it's nice over time, is what it is. And so I'm kind of playing in this space right here. At least if I really want to get a good visualization and kind of prove to myself that there's a corollary between taking a certain action and the frame rate increasing, right? For example, we saw things like this where I turned off color shifting and all of a sudden frame rate jumped up, you know, and then similarly turned on background canvas printing and it jumped up again, that sort of thing. And there might be other things here like we're rolling 12 dice. We might send that out as a message too, to go in there. I'm just thinking I could also not display it, and I could just store the data and then build a viewer for the data. But I think I kind of want to display it, is what I want to do. So to do this, we need to store like the last n number of frame rates we've calculated, and we need to put those in a queue. And so we'll take out the we'll take out the oldest one in the queue as we put a new one in, and I'm hoping that'll give us some sense of what's going on. So this will be the average, and then we'll have the other pieces there. That's kind of what I'm thinking, because otherwise I think we will have a problem where it'll be hard to visualize. If we don't normalize this over some period of time, this thing's going to be jumping up and down so much, it'll be hard to get some real good data from it. So that's kind of what I'm anticipating we're going to have to do, the problem we're going to have to deal with. I think I want a background over it, so there's nice contrast. So I think what we're talking about is we'll do a white background in here, and like a blue border frame, like something much lighter blue. Change that do that kind of a thing. And so we'll put our data inside of here, and I'm thinking to compare these. Okay, let's do this. Let's duplicate this slide. And let's take out this stuff here. I'm thinking to compare these. It might be nice to be able to have these side by side. The eyes are really good at left to right comparison. Something like this, and then changing the color for each one of these, getting a label across the top. So we'll say back, dice, front, like this. grouping these so I can very quickly change their color. All right, so something like this a little bit right here. These are too close. Then maybe some separator lines here as well. Lighten those up. Yeah, now I'm looking at this. I think I want, I kind of want to put these up here in this section right here. So I think that's kind of what I want to do to start with, to be able to visualize these. Something like that. And then I think I want to have, I guess it's fair to say we want to have one more. I want to be able to show where the different frame rates are that are important, like the key 30 frames per second piece. I don't want a line going across here like this. And we can call that 30 frames per second. So that would mean in this example data here, we're down here at 10, something along those lines like that. I think that's what I'm looking at. Some sort of tick mark or something here along the way so I can visually see where we are at, you know, the different frame rates. Presumably up near the top here, we would have 30. That's kind of what I'm looking at. I feel like if I have something like this visual, I'll be able to bring it up with a keystroke, with a command using SignalR, bring that up so I can see, visualize it, and then run tests once that's up. I'm going to throw this all on the front overlay so it's on top of everything. So the front overlay will be responsible for painting this. Okay, let's look at what we need to do to make this work. So right now, I've got this control called FPS, which allows us to change the frame rate remotely of an individual overlay. And it's got this dynamic throttling option in it. Let's look at the code for that. Let's bring up the code. Start up a new instance of Visual Studio. Dynamic throttling. Change frame rate. Here it is. Frame rate change data. Interesting. That's what we're sending. So that's what's sent to through SignalR. right here. We do a JSON convert on it, frame rate change data. If we come out into our overlays, there's the same class here down in TypeScript. So I want to change this class to give it more data, more information that we can send over. Like, I think I want an option to turn on this view. Show FPS window. That's what I'm going to do. Let's go over here to the app and do the same change here. All right. Oops, I wanted to make that. Let's do a property on that. There are some other options I want to add too. I kind of know about them in advance. Allow color shifting. Let's go down into the TypeScript. We'll do the same thing. I'll just duplicate that line, paste. We're done there. And there's another one I intend to add, which is background canvas painting. Like that. Let's get that one and bring it over here. Okay, so background canvas painting, we now have those pieces there. So now when the frame rate change data comes in, we can handle it on in the different places where we need to deal with it. So notice we're checking to see if with the active back game is an instance of the drag and back game. If it is, then that means we can see it from here, from the SignalR receiver, we can see it, and then we're going to go change its frame rate, called change its frame rate with the frame rate data right there. But now I'm thinking, with those new pieces we added, we want to pass more information in here. Let's see what's going on with change frame rate. I think I almost want to save FPS here. And do something like this. Hey, if you're already equal to that, then we're just going to get out. So there's my change frame rate. Now, let's see what's going on here. We call this in a constructor at all? Start animating, we call it. Where's the FPS interval ever set before? Is that set before anywhere? Nope, only here. So all of these are all set here, which means our frame rate, frames per second, I guess, initializes to 0 when we first start up. So we have to get a call to change frame rate, which we do when we call start animating, and that happens when we call run on the game, and run on the game is occurring in the main active front game.run there. We should see active back game.run. And that's it for those pieces there. What's interesting is I'm not sure how we're changing the frame rate in the, I don't remember if we did this or not, for the dice layer, because I'm not seeing a run call there. Let's go back and look at connection. Change frame rate dice roller. Ah, okay. We did it with a full-on function. All right. So, all right, so we've got change frame rate. All right, let's work on the code to yeah, I'm thinking I now want to do this instead. I want to send this here, this here, this here, like this. I actually want a different function. That's what I want here. Handle perf change. FPS change. Let's do that. Handle FPS change. So let's create that. Then here we're going to call change frame rate. And we're going to pass in dot frame rate. We're going to do this right here. I don't understand why that's going to connection. That doesn't make sense jumping to connection there. Can I do that? Oh, how about this? There we go. Yeah, I gotta get back into the TypeScript coding here. All right, so there's my change frame rate call. Goes up to the ancestor class, the game, that's the implementation of it. So I've done that. And now I can handle this data that's coming in here, the broader data, and make more decisions based on that individually in each place. So I've got that one in the dragon back game. The dragon front game, I'm going to do the same thing. Excuse me. Okay. So handle FPS change is now working there. Go back to connection. There and there. Now let's go into the final piece here. Let's go into this. And anybody else calling this thing? Just the one. All right, so that alone should have no impact on the way things work. Functionally, everything should still work. Just think about what do I need to rebuild, because is it enough to refresh? I think it might be. I think it might be. So let's do this. Let's just do a refresh, make sure everything's still working. I'm going to refresh my pages. Let's go get this app, shut it down. I definitely need to restart this because JSON serialization does not work with, well, that one was standing alone running itself anyway. So, but had it been running, it doesn't work, but that didn't continue. So I need to start that again. All right. Let's try. All right, now we're running. What's wrong with my dice? My dice layer is turned off. It looks like that was because I shut it down. All right, let's refresh the dice layer. Interesting, the dice layer is having a problem. It's not drawing itself, which indicates to me that we broke something. That's my take on the dice layer. Let's see if there's anything we can see really quickly in there. What happened here? Did I changed the wrong one. Okay. Let's change the correct one. It's this one right here. Oh, but we're calling it from here. Let's do this. Let's create a new function. What do we call the other ones? Handle FPS change. Then we're going to call this and pass in frame rate change data dot frame rate like that. So this will get me to here. And this is what I want to call here. Good. All right, one more time. Let's refresh again. I'm going to refresh all of them. There's the front. There's the dice. There we go. And here comes the back. All right. Now, let's initialize player data. A good test for this is to bring something up that's got animations in it. So I guess a good one we could do is we could do like giving help, for example. So let's say I give 22 health to everybody. And there you can see the animation. If we come into the frames per second, we drop it down to 5 and 5. It should immediately change. There you go. 5 frames per second. So here it comes again, 22 health. There's 5. And watch what happens when I switch to 30. Much smoother. Okay. So we're still able to send data. We haven't really changed any functionality, but we've now essentially changed the our DTO. Our payload now can hold more interesting information, and one of those pieces of information is showing the data. So what I want to do next here is I want to come in here, handle FPS change in the front game. I want to go in there and start drawing the frame rate piece. So I want to come in here and say, hey, if show FPS window is not equal to this dot show FPS window, then we're going to do something here. And we're going to say this is equal to actually, I think I can just do this. Just do that. Let's declare this. And then in our draw, or update, we've got a draw or update method in here, I think. We were writing this code yesterday to optimize the show nameplate from show nameplates. Here we go. The last thing I want to do is I want to say, hey, if this dot show FPS window, then we'll say this dot show all frame rates. Which now occurs to me, I now need a way of grabbing the frame rates from the other windows, which I think I can get, but I'll need to give some thought. We'll start here and do it on this level first, and then we will all right, let's declare this. Let me cut that. I'm going to move it down to the bottom. I like to put the methods I'm working on near the bottom so I can see those. All right. I think I want to declare some constants here to figure out what the size of this is going to be. Let's figure that out. So if we're 1920 across, I think want about a third of that, so it's about 600. So let's do that. So we're going to say frame width is equal to 650. And height is equal to probably about 330, something like that. Then we need to kind of divide up and get that kind of equal spacing across there. So we're going to say, create a new number here that's going to be called section width. And that's going to be equal to frame width divided by 3. Like that. I need to draw some text in here. So let's just do this. Let's do something really simple here. We'll refresh, take a look at it, and then keep going. What is it? Rect? Fill rect? Okay, fill rect, right like that. And now we're going to say, I think I've got a constant defined here, screen width. Screen width minus frame width. That's my X. And then screen height. So can I take this, duplicate it, Definitely give me a comment if I want to too. Okay. Like that's my upper left and X, and then now I want to take these two and do it like that. So my frame width for my width and my frame height for my height. I want to say context.fillStyle is equal to white. Okay? And that's all I'm going to do right now. And so that's our code right there. Okay. That's in our front game. All right. Let's take our front game, refresh it. Let's see. Let's go in and do some, let's do two things. We'll initialize the player data. Get rid of that green text on the screen there so it's waiting. Good. Let's put this over here. Let's go get, oops, not that one. I wanted the other one. This one. Bring it over here. And use some XAML hot reload. It's that FPS section. There it is right there. And I've got that dynamic throttling checkbox down there. I'm going to add a checkbox right next to it. I'll just select this and duplicate that line. We're going to say checkbox, call this show FPS window. Okay, show FPS window. That. And I don't think I want to change. I want to do something here, but I'm not sure what yet here for the checked and unchecked. What's happening here? Dynamic throttling changed. Dynamic throttling. Okay. Set a breakpoint here. Click that just so we can get that breakpoint. And now we can come back in over here and we can do something similar here where we can say, hey, if we're checked, new event handler, tap index reference to get to it, F2 to rename. I'm just going to say check changed. Like that. And let's go back out again. Put this one right in the unchecked as well. I want to go check this code again. What's we doing? We're just changing the dynamic throttling, and where are we using that? Okay. I'm just parsing the text to get the frame rate. Okay. I want to do something down below that, let's see. Everywhere this is, change frame rate. I want to say, hey, look, if frame FPS is equal to 0 or equal to maybe to -1, then we're going to get out. We're not going to do anything there. Okay? So if I pass a -1 into this, we're out. That's up in game. So that's going to handle both the front and the back overlay. It doesn't handle the dice roller. I'm writing code. Just don't cover the code. Yes, of course you're needed, Pudding. Glad you're here. Pudding was with us last night on the Dragon Humper show. You guys aren't out there checking it out. It's not bad. There it is right there. With the special effects that we're doing right here on the show, working on that. How's it going? Well, I am working on a frame per second window to show that so that we can monitor our frame rates. That's what I'm working on. So just now getting to a point where I can just put a window up on the screen. That's what I'm trying to do right now. So we'll see where we go with that. So I've just set this up. So if I send a -1 in, we're not making any changes. So now what that means I can do is up here, I can do something like this. How do I get the overlay name? Where am I getting that from? Passing that in here. Just using this, back overlay, front overlay, that sort of thing. Okay, so that's what's happening right there. So I'm using one of those two strings. Readability, I think I want to change this. Where's this? Right here. I'm going to cut those out of here. I'm going to create a new class, static class, so just uppercase C, space bar like that, give me a static class. I'm going to call it overlays. And then I'm going to put these here. I don't need a static constructor in there. And I'm going to change this to front. So let's first do a find on this. It's going to now become overlays.front. Done. Cool. Now this just becomes front. And it becomes public. Okay. Do the same thing. Let's make this back. And make this one dice. Back. Okay. We're going to search for this one. It's going to become overlays.back. All right, good. One more to go. Okay, nothing else found. Let's take this, move it to its own file. Editing continue doesn't like me doing that up here. Deleting constant field. Oh yeah. All right. That makes sense. Okay. I want to go. Right here. So here I want to get working my way down. There it is right there. I want something like this. We're still debugging the random GPU burning. No. The random GPU burning we fixed yesterday, and it was caused by color shifting. So we were really surprisingly caused by it. I've had some time to do some research on it since yesterday, and flat out folks are saying blur is the thing you got to watch out for. Color shifting is fast. But in the way, for whatever reason, the way we're doing it, it's not fast. And I think it's because we're, I don't know, like I said, I was hypothesizing that the front overlay was able to just suck up more GPU because it was able to get its frame rate done faster, its drawing done faster, then it would go out and get, another, give me another animation frame and it would just do it. And it was somehow just kind of shifting and had priority in some way. Now, well, it's fixed in that you'll notice we changed the backgrounds for the nameplates. They used to be color shifted and they're not. So that gave us like 20% of our GPU that was sucked up is now back. However, what I want to do now is there's a few more optimizations I want to do, but I want to have a more concrete evidence that I'm solving the problem. And so I want to look at frame rates. That's what I want to do. So I'm creating a frame rate display right now is what I'm doing. So frame rate here I'm going to set to -1. That means nothing is going to happen to it. Overlay name. Overlays dot front. We only need to tell the front that we're making a change. And then we're going to say show FPS window is equal to ck show FPS window dot is checked. Like that. And I think that's all we have to do on this side. Is equal to true. Come on. That should be right. There you go. Okay. I think I can run this now. And I think there's a chance that when we do this, we're going to see a white rectangle when we click the checkbox. All right, so let's go refresh the front overlay. So that's where we're going to be putting our FPS window. We've got a breakpoint here. Already. Run. Initialize player data. Oh, look at that. Already it's showing. That should be false. Why is it showing already? Wait. Is it true because the checkbox is true? I think it's true because of this. I think it already sent out. There we go. Sweet. Okay. Step 1 is we got a space to draw in. Good. Step 2. How are we going to do this? I think we're going to do the text next in the border. Just going to get some of the basics out of the way. just thinking about how I'm going to do that. So I can put games here, show all the frame rates. I have a line style. How do I do the lines? Move to. I'm just going to, instead of hard coding the 3 here, I'm going to just say there's a number of sections there. Then I'm going to do a for loop, go from 0 to essentially 2. And for each one of these, I'm going to say, okay, move to. And let's do this. We need to introduce a local for this. And that local is going to be of type number. And that's going to be called X. No, I think it's going to be called left. And let's duplicate this and call this one top. This code rush is changing width to height for me automatically. Screen height minus frame height is here, so this is going to be top. So now we've got a left and a top. So now we're going to say move to. I'm going to start this at 1. And now we're going to say move to I times section width. And we're going to say left plus that. So there's that. And the Y position is going to be the top. Then we're going to say context.line to. And we're going to go to bottom, which I need to declare up here. I'm going to do this again, and we're going to change this to right, and that's going to be plus frame width. Okay, so there's my line. This should give me 2 lines straight up and down. I just got to get the line style. Is it outline style? What is it? Line? I thought it was line style. We'll look it up. Sometimes this happens. I think it's fill style. Stroke style. There it is. Okay. So the stroke style, we got to get that color. Let's start up an image editing program where I can actually look at colors and get their text code. I think I can do it out here. Color. Picture online. Google's got one that's not too bad. Okay, here we go. Hard to tell for sure, but let's try that. Because we're seeing it, we're not seeing it as a narrow, thin line. Let's try that. Okay, let's refresh and see how it looks on the screen. And initialize player data.
Little cutie, Fred.
now. I don't see it, and I think that's because there's another call I need to make. I think I need to do context.begin path up here. Right? Is that right? And what do I do at the end? Draw a line? Is that it? No end path, complete path, what is it? Stroke. It's taking a while to figure that out. All right, one more time, let's refresh. Initialize player data. There we go. Nice. Okay, cool. So now we divided it into 3 sections. Those look good. If we go back to our original spec, the lines don't actually start all the way at the top. Oh, I guess they do. They do go all the way to the top. So next we need another line, and we need our text across here. So let's get our text coming up next. Let's hide our scroll. Hide the FPS window. I think I want a border on that window too. I should do a border around it because we've got a white background so we can see the edges of it. So let's draw the border next. Let's do that. Draw the border. There. Then we need to say context.move to left, comma, top. We're going to say context.line to. Oh, wait, I can do a rect instead. Context.drawRect. No, what is it? Stroke rect. Okay. And put the same parameters here. See how that works. There it is. So now we've got the border around the outside edge, which is good. I like it. Next, the labels and that line underneath. All right, so for each of the sections, let's do another for loop down here. So this, I almost want to take this out into its own method. And I want to call this draw section borders, like that. Then I want to come down and start at 0. For each section, I want to draw the name. I want to draw the title, the section title. So let's get one of these going here. So we'll say context dot fill text. Let's fill in back. The X position is going to be I times section width. It's going to be left plus I times section width plus section width divided by 2. Like that. That's my X position. In fact, since that's kind of complicated, let's create x right here, set it equal to that. My y position, well, I'm not sure what my y position is yet. It's the height divided by 2. I got to figure out what my font height is. Let's see if I've got any examples of let's see, if I look for px space, there we go. All right, so I want something along these lines here. We're going to call this the I don't know, data font. I'm going to make this Calibri. It's here. I'm going to create a new constant called title size. Like that. We'll make it 16. And we're going to come in and say context dot font, I think it's just font, is equal to title size plus data font. In fact, I can do this outside of here too, because I don't need to do that in the loop. The X position is the X right there. The Y is there. What else is needed? Max width. So my Y let's set that equal to title size divided by 2. Okay. Now I also need to set my alignment. Text align is equal to center. I'm basically getting a center point in each of those locations there. So let me trim that off there so it's a little more of the screen. So I'm getting that center point where those titles go. The text align is center, and the other one, text baseline, is equal to middle. I don't remember what these are. I'm gonna have to go take a look, see if those are right. Text baseline. JS text baseline. Middle. Yeah, so we'll set it to middle. Okay. All right. And we want I think we're just down to fill style now, is what we're down to. Let's go back to our color picker. Did I kill that? Shoot. We're going to keep it in the same. I'm going to give that about the same hue. I didn't want a lot of hue shifting going on here, but I wanted it definitely darker than the other one. So let's go there. Here's my line color. My line color is here. Let's change that line color to here. That. All right, let's refresh that and see. Oh, well, we need to change this right here. So I think I want a new array of strings is what I want here. Can I do this? Do I have a template for that? I don't. What about ls array like that? Nope. ls dot, sorry, wait, l dot a. New list of strings. Hold on, I'm working my way through it. Huh. I feel like it works here at this level. v.s, vl.s. Looking for code-rich templates here for creating arrays, and I'm just blanking out on what they are. Syntax is slightly different in TypeScript than it is in C#, I think. Let's look for array. Could use that to solve it. All right. So say back, comma, dice, comma, front. What's not liking about this? Don't like the commas. You know, how do I do this? I'm totally gonna look this up. I've forgotten how to do this. JavaScript, array of strings, constant. What's wrong with what I've done here? Well, I could do this. I can do new array. Literal. This needs the blocks apparently. That's what I need. Okay. All right. Section names are there. Then we're going to come down here where it's use section names of I. All right. Refresh. Initialize player data. Okay, no text drawn. Why not? Oh, wait. My Y is title size divided by 2. Oh, there they are. It's right up at the very top of the screen, right up there. Okay. All right. Trying to figure that out. So the Y is not that. The Y is going to be equal to top plus title size divided by 2. Let's refresh it again. Initialize player data. Actually, I don't even know if I need to do that. I may not need to initialize every single time because I think I can just come right in there and click it. There we go. Okay. So not bad. Let's increase that font size. Make it 24. And let's also draw a line underneath it across the bottom. And let's do this. Create a new class in here called the FPS window, like that. Let's take this and move them there. Let's grab an FPS window here. Put it inside the front game. And let's go look for calls to show all frame rates. If whoops, this dot FPS window is equal to null, then I want to say equal to new. Come on, what's I think it looks like that. I'm just pulling it out into its own separate class here. Show all frame rates. There we go. Next we want to declare some constants for some of the pieces that are inside of here, up here. So let's do this. Let's do line color. This. Drop a marker there, come down here. Line color there. Okay. And all right, good. Here's line color. Look who's here, kids. He's flying in. Got some. 1,000 points, you win.
He's in the house.
You win, Jessam. Okay. Guess we're working on a show FPS window. So we can see our frame rate per second, FPS speed. Based on this that I kind of spec'd out here, where we would kind of show what the current average is of like maybe the last n frame rates or last 10 frame rates that we've detected. So the average, but then also show the other ones as well and kind of show them as they kind of scatter away and maybe change their size a bit as they get older, so we can kind of see where the noise is and where the signal is. It's kind of what you can kind of get a sense of the variance of the frame rate. It's kind of what I'm playing with right now. I'm about this point drawing this line right here. That's what I'm working on here now. So draw that line. The Surly meter. Yeah, it might be called the Surly meter. All right, so let's see here. Draw section borders. I've got the line color. This is the text color. Excuse me. Let's come in here. We're going to call this maybe title color. That. Here's my title color. And change this to title font size. Let's move it up. Okay. I think those are the pieces we need. We could also argue that the font name is something that might belong up there at the top too. I'm not going to move it yet. So think about that. Think about moving that. All right, so now we need to this is the part that draws the names. So now let's call, whoa, shoot. I hit what I thought was F2 to rename, but it was undo because of my function log. Okay, so now I want to call this method, and I want to call this draw titles. Like this. Okay, so there's our draw titles part right there. So we've got some symmetry now in the code. This part up at the top is basically calculating the numbers we're going to need to use inside of it. Then we call draw section borders. Then we call draw titles. I want to put context first here, just to be consistent. Like that. Then I want to put left next. Left and then top. All right. Draw section borders, I could theoretically say, you know what, we can just calculate the bottom when we need it. So let's take out bottom from here. Take it out from here. I am, baby. All right, so now in the borders part, we can do another kind of move to line 2 piece here, where we're going to move to left, comma, top plus the title font size. And then we're going to do a line to the right, and then this part right here. In fact, we really need to do kind of two things. We need to make this the title underline Y. And set that equal to this. Small efficiency gain, but it also makes code a little easier to read, I think. Okay, do we need to get right? The second thing we need to do is get the calculation for right, which is here, and move it down. Okay, so that's going to draw the vertical separators. Draw title underline. Draw window outline. Okay, so there's the section borders. Maybe we should just draw border lines. Call it like that. Okay. All right, let's see how that looks. Let's refresh. Refresh the current page. Show the window. Show the window does not work. It looks like I need to call initialize player data. Or I've got a bug. There's initialize player data. Yeah, I got a bug. See if I can find it without having to start up a new instance. I don't see it. Okay. See if we can prod it into working. See if we get lucky. Looks like that did not have any impact. Okay. See if that has any impact. No impact. Okay. Oh, you know what I think it could be? I think it's this check here. It's not null, it's undefined. So what I really need is this. That's what my problem was. I'm pretty sure that's it. Let's see what that works, how that looks. Refresh again. No change. Oh wait. It's just slow to come up. That was weird. There's a slight delay. Well, probably does that have anything to do with the frame rate? Put it here. Change it to 5. Something else I'm noticing too is whatever I change this to, if I change any other frame rates, the window goes away. We need to fix that. That's going to be up here. Let's see where else we're creating a new instance of this. Okay, only right here. So we need breakpoint there. If we change anything in here, we want to now come in there and do that, just so that we see that piece there. Okay. It's static. Oh. All right. Restart. There's construction going on out there.
Leave it, love nuts.
Serliometer's not working yet. What'd you say, Karen?
There are so many people at our house working outside in the front, in the back, on the side.
What's the banging? Do you know what that is?
Fixing our brakes. Those are our brakes.
Okay. All right. So now if I turn that off, turn it on, and I change here, that stays up and keeps working. All right, cool. All right, good. So now we've got that. I think I want to add a little bit more margin above and below for the words back, dice, and front. Let's go work on that because our feature detectors that detect the letters in the text, they need a little bit more space there to properly identify that word, each of those aspects of the letter. For example, B, it's got the upper left intersection, it's got the curves on the right, that sort of thing. And if the border's too close, it interferes with our ability to read quickly. So I want to add to that is what I want to do. So we'll, I think, come in here and say I want to have a new constant that's a number, and we're going to say I want it to be our title margin. Like that, and I think I'm going to make it 2, so maybe 2 pixels above and below, maybe 3. So that's what I want to do. My Y position, this is where I want to draw. This is drawing the middle of the text, the title center Y. Okay. Font is that. Now draw the title underline. Here's where I want to say plus 2 times the title margin, and I actually would need to add the title margin up above here. The title center Y calculation needs to add the margin as well. All right. So that, now with that change, if I refresh, yeah, better. Now, none of these words have a descender in them. The descender is like in the letter G or the letter Y. It goes. It's a part of the letter that goes down below the baseline. So they look like they're a little nudged higher up to the top, but they're actually centered in that text across there. So I'm going to be okay with that. All right, so those are my 3 pieces. Now I need to be able to collect. I need to be able to show some data inside of them, and I need to collect those frame rates. So let's figure that out. Let's hide that window. Let's hide the scroll. Initialize the player data. Hide all the nameplates with threads. Now let's figure that out. So, up in game, we call update screen. Nothing's happening here, but I bet the descendants take over that. And that's when we actually draw. So part of what's going on here is we're checking to see here. If we are getting called, in other words, the browser animation frame request comes back and we get it sooner than our mandated frame rate, then we get out. That's what's happening here. So in order to determine our actual frame rate, we kind of need to check here, right in this space in the call to update screen. I think since we have 3 descendants, or at least 2 descendants of this, we can figure that out right here. So we can say, this is in milliseconds here. Let me do the same thing. I just want to do the rename on these places here as well. Okay. So there's a couple things that we can calculate here. We're doing time right here. Drawing time, change category to art. Yeah. Frame end draw is here. Time is moving down in this direction right here. So, the question is, how are we going to measure frames per second? We could, for example, look at the end draw time and look at only these, right? And then count the distance between these two, right here. And then from there, calculate our frames per second. So one way, let's just write that down because there's a couple ways to do it. One way is delta on the frame end, draw times, and then similarly we could do delta on the frame start, draw times. We could do delta on the total draw time, and then take to basically 1 second and divide it by the delta on the total draw time to figure out how many of those draws we could put into there. The problem with this is that there's overhead, so this isn't really true. There's overhead that we saw when we went through the profiler yesterday. The overhead looked to be easily double to 4 times what it took to draw just to get the request the animation frame, to get it called down to the right spot. I'm going to say potentially significant. But it is kind of a measure, right? What's the draw time, right? Because we're ultimately looking to see, is it one way different from another? So I think you could almost arguably I'm leaning towards this one right here, is what I'm leaning towards. Even though the number, the FPS number, is going to be higher than what it really is, it's kind of telling us what that potential is, and I think it's a good delta to measure. So it's essentially like what we could call as like a raw FPS or an effective FPS. It's not the true frames per second, but it's how many we could do if there was 0 overhead. That's kind of what we're talking about. So what happens is we measure the total time to draw, we take that number, we put it underneath the second, so 1 second divided by that total, and that in that moment is going to tell us how many times we could draw that bit per second. That frame, that particular frame per second. And then we'll be able to calculate that regardless of our actual frame rate. Our actual frame rate is, I think, going to be closer to the delta of one of these two. All right. So let's do this. Number. Oh, okay. Putting flying around. All right. Seems confused, Mark. I missed that from earlier. Sorry about that, buddy. Yeah, I I feel like I'm kind of working my way through this. Kind of taking the staff, pushing it out there. Listen, I think you got to follow genre by the what genre you want to switch it to. Like that. Or what else do we have? Action, funk, EDM, rock. Okay. Okay, so start update to end update, that's going to get us those two pieces. And then I want to say this dot calculate frame rate. I want to pass in the start update and the end update. Like that. And let's declare that. And now, let's actually calculate both of those. Wow, check that out. That was cool. So let's do like this one and this one right here. So we're gonna say we need our last update time. Okay, so there's my last frame update. I want to set it equal to this at some point. So there, we're going to say, hey, if last frame update has any valid data, then we want to come in to close the door for the dogs. And, yeah, a lot of distracting noises happening today. So if that last one exists, then we want to say time between draws, time between frames. So that equal to and update minus this dot last frame update. Time for this frame is equal to end update minus start update. Okay, next I think what we need is a queue. To forget how to do this, let's ask the internet. JSQ. I think there's just an NQ method, is that right? Hold on a second. Q shift. So it's push and then shift. Is what we do. Arrays have queue methods. I'm not seeing a queue method here in this example here, but that may be push, pop, shift, and unshift. Oh, there you go. Yeah, putting exactly. Thank you. Yeah, so shift is what we want. Take that out. Unshift takes it back the other way, I guess, right? Let's see. Push the 2, push the 5. Shift it out. And then the 5 is up there. That's what we want. All right. So we need to have a. Look who's here, kid.
Surely Dad is in the house.
How you doing, buddy? Somebody is very quiet today. Am I quiet? Check, check, check. Oh, wow, I am quiet, aren't I? Check, 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 check. Why was I so quiet? Check. Thanks so much, Surly. Nimi Kakula is in here. Hello. Was nobody paying attention? I don't know. I've been talking to people. I think everybody's cool with the quiet approach. People are just updating with their earphones there, I suppose. By cranking up the volume, I probably blast out their ear. Pudding says, I've been paying attention this whole time. Yeah. I just like the quiet. It's fair. Wait. Nimi Kakula. Did I get it? Am I getting it close? Nimi Kakula? Deaf now. Sorry, Codebase Alpha. Of course, Surly had to ruin it. Surly, we're making a Surly monitor to watch frames per second. And, you know, when you try to take us out with all your, you know, your stuff. That's what we're doing. So let's see what we're doing here. So time between frames is here. And now I want to create a queue here. I guess I want to do two things. I want to create a constant that's going to tell me how many my history, my FPS history count. And let's set it to 10 for now. GPU usage is too low. Grovosaurus. All right, Grovosaurus. Fine. You claimed back a load of GPU resources. I feel compelled to use them up now. Yeah, go for it. Go be compelled. I'll be working on my drone control app over the weekend now. It's okies. We'll break the code eventually again. Well, I don't know. We're getting better. You're probably right. Flying drones in formation. That'll be fun. Okay, that's going to be really fun, actually. All right, so time between frames. All right, so let's do this. Var. We're going to call this the time between frames queue. Like that. Whoops, just like that, I think. And time for each frame queue. We'll call this draw time. Draw time for each frame queue. Like that. So now I think what I want to do is this, I want to say this dot push the draw time for this frame, and I want to say this dot, that. Then I want to say, hey, if this dot count length is greater than game.fps history count. You can change that to a while. Do this dot what is it, shift? So just take it out. I just want to store the last 10. That's what I want to do. I suppose it's fair to also, you could already say just do an if there. All right, so I want to do that. Then I want to bring this down, and I want to get rid of that one and change it to the time between frames queue. This is FPS. Surely, only 11,000? You think you lost something? I don't think you lost something. And I need to duplicate this this is going to be time between frames queue and push time between frames. So there, that calculates and saves all that. I think I want, yeah, I'm okay with that. So if we have some sort of last frame update time, then we're going to add some data to it. And we're going to make sure that the data does not get too long by doing this. Okay. Now we have data, the time between the frames, and the draw time for each frame. Next, we need to get it. So let's go back to the Dragon front game and show all frame rates. Here we go. Here's where we want some of that data. Now, I think we had code in connection that's useful here. For these two, active back game and active front game are declared. So these globals are out here declared. So we essentially want to see if there's an instance of them. The active back game is the one that we're kind of interested in from the from here, because it may or may not exist. We do know from here that the Dragon front game exists because we're calling it from it. We own it. So I almost want to say, let's show all frame rates. Let's pass in this as well. Show all frame rates. And we're going to say Dragon front game. Oh, sorry. Hold on. Like that. So pass that in. And so now what I'm going to do is I want to say this dot show data, show frame rates. I want to pass it a column number. So we'll start with the, we'll say, and I want to pass it a game. So we'll say this is going to be in column 2. This is going to be in column 0. And let's declare this. Show frame rates. This is going to be my column. I want to change this type to just game. That's the ancestor class. Like that. All right, getting closer. Okay. So there's the column, there's the game. I also need a context, I think, and a now in here. We're going to pass in here. I'm not sure I actually need the now. We'll definitely throw the context in there, though. So from game, we have what? We have the draw time for each frame queue. And we have the, what's the other queue? Time between frames queue. With the last one in the array is the piece that is most recent. All right. So let's do this. Let's come in here and say calculated FPS based on draw time is equal to 1 second divided by the game.time between frames queue of dot length minus 1. I think that'll give it that to me, the calculated FPS based on draw time. You know what we can do for now? Let's do this for now because we've written a lot of code. We haven't checked to see if it works yet. Let's just put that text out there. We've already got the same font here. So section width is a parameter we'll pass in here. Looks like I need left in here as well. Okay. So the text I'm going to draw out is going to be my calculated FPS based on draw time. So this number is going to likely to string. This number is likely going to just be jumping all over the place like crazy. But I just want to get some data out there, make sure, you know, everything's like I'm expecting it to be. This location here should be the FPS window dot my title size plus my FPS window dot title margin times, I'm going to say times 3 times 4 just to get it a little bit near the top, but below the line. Is that right? But then if we're drawing in the center, I gotta then, let's do this because I'm going to change the location of this anyway. This is just temporary code. I'm just going to add 50 to it. Let's see if that works. See if we get really lucky and we don't have to go start up a separate debugger, separate instance on this, and just see if we can get some painting out there. All right, initialize the data. Show FPS window. I don't see it. Okay. I'm sensing a problem in here, is what I'm sensing. I'm thinking the problem is maybe here. Let's try this. Oh wait, hold on. It's up at the top. It actually is working. I forgot to do the top. I need to pass the top in here too. So we need to pass the top in. You can see it right up there, right above the pudding, right there. So you can see what's going on there with our with the calculation. But the number's unexpected to me. I'm expecting much higher. Oh, because we're in milliseconds. So 1,000 milliseconds divided by that should give it to us. Okay, so now this is going to be top plus this. Then I've got left number. I want it to be top number. And then I want it to do the same thing here. Just select that. Hit duplicate selection. Look at that sweet Coder's feature helping me out there. All right, let's come back in, refresh. Cool. It's going to be long. The number's going to be long. I don't want to actually show it as a number anyway, so let's just oh, I forgot to do the plus 50. So cool. We're now at about, based on the draw time. Don't you want integers only? Yeah, I don't know. I actually don't think I'm not sure. I want to actually have a graph kind of thing going up and down is what I want to have. Let's add 50 to that. I don't think 0.1 will make a difference. Fine. How do I change it to integers only? I forget how to do it. I got to do math.round, I guess. That's what I'm going to do. Math.round. Like that. Let's refresh it again. Yeah. Just bring the window up. Okay. That's based on my draw time calculation, which is kind of interesting. The effective frame rate was going to be way less. This shouldn't have any impact on it. Ooh, it does? Now it doesn't offset to the sides and it can be read easily. Yeah, you're right. What's weird though, is this should have no impact. If I'm using the right number, this should have no impact on it. On the draw time. Am I using the right number? Oh, I'm using time between frame skew. I used the wrong number. Okay, so let's, doesn't reach 30 though. This is based on the time between frames, which is already throttled by my code so that I'm controlling it. That's why the numbers were changing. I wasn't expecting them to do that. Let's duplicate this. Let's get this to use the other queue, the draw time for each queue. Like that. And this one is going to be FPS, actual FPS is what I think I'm going to call this. Actual FPS. So there's that one. So now we have the calculated and then we have the actual like that. Like that, actual FPS. Okay, and I need to crank this down, bring this down a little lower, make it 150, like this. So the actual color, let's make that kind of like this, but let's shift it around just a little bit. So that's my red, green, blue. I want to make it a little more, I want to swap the front and the ends. So it's more redder. Like that is what I want it to be. All right, let's do it again. Okay, now we should see a much higher number. Okay, yeah, so two things going on. The number that's super high is based on how many of those frames we could do on the front overlay, we could draw per second. What's interesting is actually I haven't even initialized the front overlay, so there's like nothing happening in the drawing right now. So we've got these really high frame rates that are, that's how many frames we could draw in a second if there was no overhead, nothing else we needed to do. That's assuming that calculation is correct. Let's go initialize player data. Hopefully that'll drop down once we start drawing things. Yeah, so that dropped down. It was up about 2,000 to 3,000, and now it's lower. Let's do an effect like, let's add some health. Nice. Frame rate drops down to about 100, even 89, something like that. So now we have a way of measuring kind of the performance of things here. I want to go back and try that again. 22 health. And that stays at 25 the whole time. What's really interesting is the effective frame rate drops pretty low. The one in, the actual frame rate is the one in red. So that's what's happening there, right? If I change this to 30, that should get closer to 30. Well, it should, but it's, I think, not able to. What's my GPU at right now? All right, GPU is pretty high. So that may be why that frame rate, and we're not able to hit that 30 frames a second there. If I switch it to 5, there you go, you see that drop? That actual frame rate drop. So we've got some noise. I want to average that out. That's what I want to do. So instead of using this number right here, I want to get the average from it. So let's come in here and we're going to say, ln, we're going to say average time, and then let's grab the rest of this text, between frames. So there's my average time between frames. I'm going to say equals this dot get average. And pass in that. And then I also want to come down here and say average draw time for each frame, like that. Let's declare those. That's going to return a number. I want to now use this here, but I don't want to delete this code here because I actually want to use this code. I want to create most recent draw time. Most recent FPS, maybe like that. And I want to do this. I'm not going to use that yet, but I also want to do the same thing here, which is going to be my most recent draw time draw time per second. I don't have a good name for this, but that's what this is here. Most recent draw time, draws per second. Maybe call it draws per second. All right, so now my actual frames per second is equal to average draw time for each frame, 1,000 divided by average draw time for each frame. And my calculated FPS based on draw time is equal to this, average time between frames. Cool. Now my get average. So let's call this just the Q. And we're going to say total. So if there's not Q, there's nothing in it, then we're going to return get average. Let's see if that calms it down. So right now you're seeing that thing jump up and down. Let's see if it calms it down. The jumps should maybe be smaller. That's my hope. And if not, we'll increase the number of pieces that we hold into it. Let's refresh that. Initialize player data. It's interesting when we first start. Wait, did I swap the numbers up? I think I totally swapped the numbers, the top and the bottom. And I need to round my average time here. Okay, so that I need to do. All right, one more time. Okay. What's really interesting is that we start with an actual frame rate of 40. It should be initialized to 30, not 40. So I'm not sure what's going on with that. But also, it's cool because we're seeing what looks like smaller changes. Because we're averaging out across 10 frames, I think we're seeing, it feels like we're seeing less of the noise going up and down. Let's change the frame rate here. So let's actually click on one of these for the front, change it to 30. Nothing happened. 25. Nothing happened. What's going on? There's like a calculation error in there. Something's definitely wrong. Okay. Why is that? Let's make sure we're storing the right data in here that we're expecting to. The time between frames is equal to end update minus the last update. This, I can actually put this down here. Okay, so time between frames is the end update minus the last frame update. So that's the time between the actual frames when we've actually drawn. Okay. So we get the average of all of those. Average time between frames. I think it's the same thing, the actual FPS. I think it's the same thing here. It's 1,000 divided by that to get that FPS. All right, let's try that. Let's see if that adjustment works better. Is it me or is the stream lagging? Hold on a second. Let me switch to my second computer that's doing the actual streaming. Looks like it's okay now. Got to upload. I'm in the green, 2373 upload. Okay, let's refresh. Latency to broadcast are 3 seconds. Seems pretty stable. All right, that's better. Just change it to 30. Still at 25. Change it to 20, and it drops down. What's interesting is it drops to like 16 or 15. It's like there's a math error, or maybe it's just trying and it just can't get that frame rate. Change it to 15. Change it to 10. Looks pretty solid at 10. 5. There you go. 15. It's close. It's between 15 and 16. 20. 30. Yeah, it seems to peak at about 25 frames a second. Check, check, check. Looks like my volume is loud. It's looking like it's going in the red here. Does it feel like I'm clipping? I'm going to drop this down a bit. Check, check, check. Check. Check, 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 check. Check. All right. Let me know if sound's okay for you guys. It's a bit loud. It is a bit loud. Check, check, check. How about now? Check, check, check. That looks better to me. Okay. Let's stress it. Both numbers drop when we stress it. Let's do it again. Hickey Artemis is now following. Thanks for the follow. So I'm just trying to figure out how effective is this going to be in comparing two different approaches. So if I come in and say turn on an option or turn it off, it really looks like the number in red is more useful, right? That's the actual frame rate based on the draw times. If I tell it my draw time, my frame rate should be like 30 frames a second, and the most it can give me is 25. Let's get the back overlay in. Let's see what it's doing. I'm actually doing both of these. The back game is not active. Oh, shoot. It's not active from the front game because it's kind of into its own browser. It's never assigned in the front game. How the heck can I show its data? How can I get its data? I got SignalR as an option. I have another clever approach to this. And that is that each one of these panels is drawn by one of the overlays. But that also means that the pieces drawn by the front overlay will kind of cover up some of the elements from the back pieces. But I'm thinking that might be the way to do it. So each panel is drawn I think I need more data. Let's do a couple things here. Let's get more data. Let's change this to change it to 40. Stress test it. These are the dice. And due to dynamic throttling, it's going to drop my frame rate to 10 anyway on the front overlay. If I turn off dynamic throttling, yeah, we really need the dice data. We can't really stress fairly here. Hold on. Let's turn off dynamic throttling. Why am I maxed out at 25? I feel like there's some hard-coded frame rate, max frame rate kind of thing going on here. Yeah, it sets it to 30. Calls change frame rate. I don't know why it doesn't go above 25. Let's turn off the nameplates. The clock is still being painted at the top. It seems unusual that it's not jumping up above 25 frames a second. Let's see what we got now. I know where it's coming from. I think I might know where it's coming from. I think it is coming from an internal limitation. Is it from my settings in OBS? I think it's an internal limitation that's preventing the request animation frame coming in too fast. That's what I think is happening. But I'm not sure where that is. I'm not sure. Where is that? Looks like output's frozen a little bit. There we go, just kicked in. Sometimes changing options in OBS causes things to freeze for a little bit. OBS is not responding. I'm trying to bring the options keys here, the option page up here. Yeah, I'm not seeing it here, but I almost feel like there might be some limitation provided by on the system that just keeps the frame rate at 25. $15 is weird. Clicking on 15 drops it to 10. It feels like there's a math error in the code. 20 brings it to 15. 25 gets it at 25. 10, I think we saw, did bring it down to around 10. 5. Why does 20 get it to 15? That's so crazy. I just can't imagine code that does this. All right, we got to, how are we going to get the data from the others? I don't think I want to send it via SignalR. I think I want to have each layer responsible for drawing it. Drawing one of the sections. So, let's add a constructor in here. We're going to change the architecture of this a little bit. And what column number it's going to be at, it's going to be column 2. I think that's what I'm going to do. And so now we're going to say we need a string here. And this is going to be a public string called label or title. And we want a number here that is column like this. Okay. So now my frame width is going to be 220 about. Num sections is gone. Section width is now actually frame width. Num sections I shouldn't need anymore. Draw border lines. We don't need that really. That's a little bit different. We're going to take out sections here. But I think we want to pass in the column. Well, we've got access to column anyway. We're setting that. Oops, I deleted the wrong thing. I want num sections to get rid of that. Ryan Tupos raiding with Party 4. Thanks, Ryan, for the raid. Welcome, everybody. The vertical separators we don't need anymore. Which means we don't need the bottom. Looks like we don't need section width. So we're not doing this anymore. Wait, well, how did this go away? Duplicate identifier game. How did that happen? What did I do? How did I lose game? Oh, that's not what I wanted to do. Let me hit undo a little bit here. There we go. Maybe I hit rename on it. That may have been what I did. Okay. The title, no section names. Yeah, welcome, Raiders. You should make a raid fanfare. Okay.
You won!
How's that? That's not bad. Not bad for out of nowhere. You know, to welcome Raiders instead. There you go. Just wants to say it's a brand new car.
It's a brand new car! You know what time it is?
It's time for a
Dance Battle!
There you go. I can play with buttons. Disclaimer.
Disclaimer! Mark doesn't know Jack!
This felt kind of mean. Jeez.
Oops!
Yeah. You should apologize.
Sorry-ish.
This is when you play Codebase Alpha's Fanfare and Dance. Oh yeah, I can do that too. Codebase Alpha is good. Where's Codebase Alpha's Fanfare? There it is. Yeah, something like that. We are trying to visualize the frame rates. We're just collecting the data, looking at it. It's showing up in a frame rate window. I'm popping up right here. I just realized I got to kind of break this into 3 different parts because each one frame rate, the piece where I'm drawing from, the front overlay, doesn't know about the other back ones and the 2 behind it. So each one is going to have to draw its own frame rate is what it's going to have to do. I've created a class called FPS window, and I'm revising the class so instead of drawing into 3 sections, it just draws into 1, and so each place will specify the section it draws to. So now when we're in this draw titles function right here, this is just going to be this dot title, like that. That's the text that we're going to pop in here. The X position, though, we need to kind of calculate that. The left is a little tricky because I'm kind of doing this to calculate it. But I think what I want to do is, I think I want to do this. I want to take my section width. Oops. And I want to make it a read-only constant. Let's get rid of that. Come up here, type in QN for read-only constant. We said that was 220. All right, there's my section width, like that. Frame height, I want to do the same thing. Anywhere else, that's it. Frame height is going to be 330. Okay, so now we've got our section width, our frame height. I think my left and my top, I want to calculate here in the constructor, and I want to change both of these to be fields. Like that. So that is going to be the left and top of the individual section that we're going to draw. Okay, and now we're down to this. And I think it becomes that for draw title. I think that's it. Let's see what happens if we refresh it. And if we refresh it, we should see only one section draw. How do I win the fight against the fear of learning something if it looks really intimidating? Is the question. I don't know. Here's my answer. You're going to hate it. If you run away, that can be a win. Run fast from something that looks intimidating. And then give it some time. Go back and say, okay, I'm going to take it a piece at a time. Right? I've got a number of intimidating things on my plate. They look daunting from the standpoint of learning curve, right? But I've scheduled time for them. I've said, okay, here's when I'm going to work on it. Like later this afternoon, I'm going to go dump into some stuff that I've been kind of holding back so I can learn more about it. And I'm just dipping in a bit at a time. And I think that this approach is good. And then you also set your expectation so that the win is derived from the attempt, not, anything else. In other words, if I'm scheduling time, like right now, I say, even though I don't know the answer to the stuff I've got to learn later today, I have a win because I've scheduled time to do it. Right? So I have the win already, and that's because my threshold for success is scheduling, right? Putting time aside for it. Spending time in. It doesn't have to be that I, accomplish, compare myself to anybody else. I just have to go in there you know, and my goal is to spend some time in there and try to learn something. But the goal is to spend time. And if I can do that, I've got to win. Right? So that's how I think you do it. If something looks really intimidating, that's what I would go for on that. I would look at, I would change your criteria for success so you have a win no matter what. And don't be afraid of putting something off, right? Until your mind's in the right mindset to do it. Because like if you're tired or you're not focused or whatever, you're distracted by the learning curve, you know, the apprehension about the learning curve, you're not going to be in a good state of mind to really learn. And so I think that those are the ways that you can approach that. Okay, so let's see. Let's turn it off, turn it back on. Cool. And now we see only the front, but I'm not seeing any data. So our data is in the wrong place. Let's go figure that out. Here we go. This, I think, is my problem. My left is passed in. Show frame rates. I don't need to pass in left and top anymore because we've got them. We own them. Same thing here. Let's do that. And same thing here. Let's not pass those in anymore. And guess what? We also own these. Let's just do this one thing at a time here, though. So left and top, we don't need to pass those in. That means anywhere inside here where we're referencing them, we're just going to say this dot left. Now we don't need to do this anymore. We're just going to say plus section width divided by 2. This one is going to be this dot top. And this one's going to be this dot top right there. Okay, that looks and feels good to me there. Let's go get into draw border lines. Where are you? We don't need left and top. This dot here, 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 here. Okay, good. Let's go back. Draw titles. There's draw titles right there. Let's get rid of that. This and this. Okay, let's see what else we don't need to pass in anymore. The section width, which is in draw titles, the third parameter. Okay, we're not using num sections either in draw titles. So we can just clear that out, simplifying the code. Cool. We don't need section width here for show frame rates. Okay, that's it. There. And look at how this code is sweetly falling into place here. Frame height. Let's get rid of that one first. There's one gone, and then the other one is section width. Just using CodeRush's tab to next reference here to get all of those. Good. We don't need num sections anymore. All right. I think we only need context fill style inside of draw border lines. I think that makes more sense there. All right, if we make that change, we should see the frame rate start to appear. Let's see if that works. Let's refresh the front overlay. There's the refresh. There we go. Let's initialize player data. So the number on top is the potential frame rate we could achieve if there was no overhead based on the actual time it takes to draw. So that's kind of a really nice measure of what is the weight, the heaviness of the drawing. And if we were to throw some stress at it, you should see that blue number drop down. And the red number eventually drops down too. Because it's just, the weight is so much, it can't get that frame rate that it needs. Right? I'm trying to figure out which of these two numbers is best for the best metric to use. Trying to figure that out. Also trying to figure out why even though I'm trying to draw more than 25 frames a second, it's limiting me to 25. I think it's an OBS issue, is what I think it might be. Let's see if we can see that. OBS frame rate 25 for browser. Oh, wait. I know where it is. I know where the option is. There it is. It's there. It's an OBS option here. So there's my frame rate right there. If I pop this up to 30, is that going to, I guess I got to click OK. Is this going to suddenly, what refreshes it? Okay. So let's see if now we've lifted up that limitation. There it is. Okay, cool. So that's where it was. It was an OBS setting. So now we've got it at 30 frames a second. Cool. Wonder if I have that limitation in on the other pages here. Do I have that on the dice? Holy cow, my dice, I set the frame rate at 20. Let's bump it up. Since we're able to go up and down and control it ourselves, let's do that. And then let's do the same thing for the back overlay as well. Back overlay was limited to 25. Let's pump it up to 30. Okay. Interestingly, yeah, I was just noticing the frame rate drop down. I think out of these, let's stress it. Let's initialize and then stress it, and watch what happens to the frame rate. So we're at 30 frames a second. Here comes the stress now. I think the red number is an okay number to use as our metric. Even though the blue number is on top is kind of more precise because it's really measuring actual draw time, the impact of actual draw time on the actual frame rate is significant. We're actually seeing that. We're seeing that change here. Let's bring that up to 30. Let's do it again. 22. Let's do damage instead of health. Let's do 22 health. That seems to be pretty consistent, dropping down to about 8 frames per second there. All right. Let's visualize this. Let's change it from numbers to actually like kind of a graph in terms of where we want to put this. And I think I'm getting rid of the other number. Not going to use it for now. Okay. So I'm not sure I want or need the most recent FPS. All right, so how am I going to visualize this? I think I want a max frame rate. This is determining my y-axis. So I'm going to say it's at 30. So the very top of this, right up there, we're under the line under the word front. That's going to be 30 frames a second, or close to that. It'll be 30. And then down at the bottom will be 0 frames a second. So I'm going to have a line that kind of indicates what my frame rate is. All right, so max frame rate is 30. The actual top that line can be, I want to be able to put the word, that number 30 next to it. That number that's 29, 26, whatever, that number next to it, which means I need to go down half of that font size plus hold on a second, let's do this. Top graph. Y. I'm not liking the name of this. This is going to be equal to this dot top plus this dot title size. I thought it was a title size. No, it's not this. It is FPS window dot title size plus FPS window dot title margin. These are the pieces I want to work with here. The top plus the title size plus 2 times the margin should give me that line. In fact, I think I want to save that calculation because I actually am going to do that here. Title center Y. That's not the one I want. Title underline Y. This is the one I want. Let's change this. All right, let's get rid of that. Let's go up to our constructor. Get that in there. All right, so there's my title underline Y. So that's the line right there at the top. Now I want to say this dot graph top Y is equal to this dot title underline Y plus the title size. Since we're drawing text in the center, it's going to be title size divided by 2 plus the title margin. There's my graph top Y. That's going to be the topmost point that we can draw a line or draw text. And when we draw text there, it'll be centered there and we'll get that title margin so that it won't be too close to the line above it. So there's my graph top Y there. That's 30 frames a second. That's when we're at that point, we're at 30 frames a second. So now, I don't need this here. Don't need to calculate that. So the graph top Y is here. The distance that we have let's get a graph bottom Y as well. Graph bottom Y is equal to screen height minus that. And this title size divided by 2. I want to put this in parentheses here, but I'm just noticing I get the same thing here. So we're going to say title half height plus margin. We're going to set it equal to this. And we're going to add it there and we're going to subtract it here. And so theoretically, that bottom point is where 0 frames are going to be, and then we can drop it all the way to 0. We'll still see the 0 on screen, and it won't be off screen. That's kind of what we're looking at there. So there's my top Y and bottom Y, right, like that. Then that also means my this dot vertical graph. Let's change it to graph vertical space. Vertical height. Maybe just graph height is equal to this dot graph bottom y minus this dot graph top y. Like that. So there's my graph height. All right. With that information, I should be able to figure out where to put it based on the frame rate. So the max frame rate is here. I guess my min frame rate is always going to be 0. We're going to assume that it's always 0, which is down the bottom. The number I want to graph, I don't want to use this number. I want to do the actual FPS. That's the one I want to do. I want to kind of group this code together here. And what's this calculation here? X is equal to this dot left plus section width divided by 2. Okay, that's all good. I want to comment out this. This is my average draw time calculation, which I've decided is not as useful. I might clean all that up and just not track it anymore. The most recent, I don't care about, but the actual frames per second, I do care about. Okay. All right, so now let's draw this frame rate right here. Let's right now just get the frame rate in the right place. Hey, baby, how you doing?
I'm great. How are you?
I'm pretty good. No, don't put things in my show. This is my show. Come on, don't
Eat it.
don't. I don't even know what's happening now. Get in here and say hi to everybody.
Hello. It's me.
There you go. There she is.
What's going on up here?
We're see that over there? That number? That's the number of frames that we can draw per second. Right now, 30 is good, but if it drops down too low, it's bad. And so we're creating some data visualization for it. Jetsom's out there. Says,
I want you to hi. I want you to increase it. I think we went around 50
50?
at least.
Okay.
Otherwise, I won't be satisfied.
Okay. What about this method that I was working on over here? What do you think I should do with this method?
Ooh, that's messy.
It is, isn't it?
You should refactor that.
I should. You're very good. I don't know why you don't code all the time. You're so wise.
I'm painting a mural right now.
Yeah. Bigger is better? Ask Jetson. It's a family show. Family show? Just can't answer the question. All right. I love you.
Yeah?
What are you painting right now? A mural?
Yeah.
Is that like a painting tool?
Oh, yeah.
Okay, stop. I don't know why you're. This is not your space here right now. Okay? No. How much are you wishing? Oh my God, she's got the most excited look on her face, and she's got a stick and she can poke someone. Get out of here! Get out! See this wallet? Get out of here!
Oh, yeah, I'm taking it. You just threw that at me? It's mine now.
All right, Jetsom's going to ask that question on the next Dragon Numbers.
Feeling a little light.
Yeah, because you're here. You keep coming here, lightweight.
Sorry.
Get out of the way.
Pardon
Get
me.
out of the way.
Excuse me. Pardon me.
Get. Look, I'm doing a show. I can't work with that thing poking my face. Oh my God, do you guys have to worry with it? She pulled my earphone out. Do you guys have to work under these situations, kids? Oh my gosh. Okay, last time I say hi to you during a show, please stop. Nobody wants to do this. It's an invisible surfboard. Look at this. I don't even know why this is here. All right. Let's focus on this. Let's get this done. So I need to map. I need to figure out where to put this. I need to get the Y position on this. So I've got my average time between frames, and I've got my actual FPS. Then I think I want to get my, I'm going to call this my inbounds FPS for the purpose of calculating the positions. I'm going to say this is equal to, and I think I've got something in a math utils out here, math.ex that I built, dot between inbounds, bounds. Oh, come on. Is math.ex mine or not? Yeah, I thought I had my inbounds in here. I definitely have in between for my random. I guess I don't have it. Guess we'll write it. Inbounds, my min is 0 and my max is 30 and the number is my actual FPS. So I just want to make sure it's bound to that location right there. Is there in math something already here? No. There's min and max. I just wanted to do kind of both in one call. All right, let's declare this. Clamp. Look at clamp. I got clamp in there. I'll take clamp. And it's value, low bounds, high bounds. All right, so we'll clamp that. We'll call it clamped. Clamped FPS. And now the clamped FPS is going to go from 0 to 30. So we basically know that the distance, that 0 to 30 distance maps to my graph height. So hold on. I think the answer looks like this. The Y position, I think it's equal to the clamped frame rate times the graph height, right, divided by the max frame rate. So if we are at 0, this thing is going to go to 0. If we're at 1, we're going to be 1/30th of the way up of the graph height. So that looks correct to me. So that's going to give me a number starting at 0 to whatever from the bottom, but the actual line should be the screen height minus that. And I think that's my new Y position for the line. Then I want to say context dot move to, and I want to move to this dot left and the Y position. Then I want to say context dot line to this dot. Do I have a right yet? Looks like I don't. Y position. Let's go create a right. Is it going to be, it's going to be this dot left. Plus the section width. Like that. Okay. There's my line 2. And let's, I guess, where do I want to put that text though? I guess I'll do this for now. The line's going to be right through the text, I think. And let's do Y position here for this text. So we'll see the line and the Y position. We'll just kind of play with that. Let's make sure that kind of runs. And before we do anything else, let's see what that looks like. Oh, I didn't have the stroke call. Let's add the stroke call to there. Context stroke. Also, I want to have context dot stroke style equal to FPS window dot line color, like that. Let's try again. Yeah, you can see it moving down. It's not bad. All right, refresh the cache. Okay, there it is, the strike through that's happening there, kind of thing. Let's initialize player data. Let's stress it. Cool. Let's do it again. What's interesting is it seems to start to drop when the text comes on screen. Okay. I'm just working through different ways of visualizing this. I want to see what the impact is if we just do it around one player. Interesting. I think I want a graph. I think I want a graph over time is what I want. So the question is, how far back in time do I go? Depending on the frame rate, in other words, I could go back 10 data points in time, but 10 data points might be 1 second or 10 seconds, depending on my frame rate. Or it could be a third of a second. So the question is, do I change the number of data points I go back in time to look at. So we've got our x-axis doesn't change. And I think that's the answer. I have to do that, which means I have to figure out how far back to go, how many of these to go back and count to get my data that I need to draw. But because I have the time between each frames, I can count backwards. I know that time, so I can calculate it. So I basically, I think what I want is something that says, get me an array of everything in the last number of seconds. And then it's going to give me that array, and then with that array, I can go and draw all of those points. And then, you know, see how many points back I have to do that. That's one way. Ooh, another way though, oh, it might even be easier. There's an easier way to do this, I think. I've got the data. Simply just draw the data until I either run out of space or I run out of data. As long as I track the data, I'll be fine. Because it's a queue, the one that's pushed in there is at the front. So that should be good. Although showing the average now may not make sense anymore. Maybe it still does. Because it's a number, I don't want it popping up and down. All right, let's do this. Let's take the number and move it off to the side. I want to put the number, let's do this. Let's go over here. I want to throw the number, I want the number over here like this. And then over here, I want this thing going like this. Right, so this is always the most recent time and this is later. This is older. Or do I want to do the opposite of this? Traditionally, I think we do it the opposite way, don't we? It goes like this, and then this guy's over on this side, right here. So this guy's here showing me the current value, and then we're drawing this over here. And I'm just going to go back in time as far as I've got, how much data I've got. So if I've got 30 frames a second, go back, how many seconds? 1, 2, 3. If I see something come in, how long do I want it to keep it stay on screen? 5 seconds? I think 5 seconds. All right, if I want it to stay on screen for 5 seconds and I'm running at 30 frames a second, I need to hold at least 150 of these in memory, which means, let's go find that. Where is it? The all right, here we go. History count. 150. So I'm going to throw 150 in my history. I'm going to have 150 of those entries in there. All right, next we're going to put the text on the far right side of that. So the text location, show frame rates is here. This is where we want to do the graph. I want to change this to graph frame rates. And now let's look at the text. So the text is here. let's change our, we can use our right position here. Fill text. So instead of saying X, we're going to say right. Is X even used anymore? It's not. Okay. So there's my right. Is that a dog that wants to go out? Hey, you're okay. You're okay. All right. Let's see if that dog is okay or not. Dog says no, it's not okay. Give me 1 second. There you go. Okay. All right, so we're going to throw it out over on the right side, but I don't want to center it there. I want to right align it. So context dot align, text align is equal to, pretty sure it's just right. Like that. Now this, I want to move this down. So we'll draw the text first. Then we're going to say, let's measure text on this. Get the width of that. No, wait, let's do this. Hold on, I don't want to get the width of that actually. I want to get the width of 00. Maybe 000. I just want always to get that width is what I want. And now I want to move back from there, and that's going to be my kind of X starting position is what I think it's going to be. I kind of need to count backwards here, count to the going to the left. So we're going to say X. We'll call it right edge. Right edge. It's going to be equal to this dot right minus text width. And now I want to go through my segments, and I want to iterate backwards through my segments. Time graphed, set that equal to 0 here. And now I want to go so the older ones are at the end and the newer ones are at the beginning, I believe. And so we'll see this visually if this works out, because the graph will kind of follow the piece, right? The whatever the value is we specify. So the value, just important to note that the text I display is the average, the actual FPS average. And I just realized the average FPS, this is going to get average across the entire queue length, but I might want to limit that, I think. So I want to say something like putting back, entries to count, something like that. If queue length is less than entries to count, entries to count is equal to queue length. And then we're going to do this. and we're going to do this. So now my average, I can say get average of the most recent, like say 10 entries. So now my average is closer, much closer to what the current one is. And that way it doesn't go out to all 150 frames, which would produce results that are not quite jiving with where its position is in the frame. So that's the average that we're displaying. Okay, there's my right edge there. My left edge is this dot left. The graph width, that's equal to my right edge minus this dot left. That's my graph width. And I said I want that to be 5 seconds. So say, let's do this. We're going to say this. Well, this should be graph width. And this is my time span. I don't know. It's equal to 5,000 in milliseconds. Maybe this is the graph time span. Like that. So now I've got my 5,000 milliseconds, and I'm getting my, so time between frames, that's here. I want to go 5,000 milliseconds across. I want to see where we are here. So the left position for that line that we're drawing now, the left position is equal to right edge minus this length. This is in milliseconds. So my right edge, actually, I should be working in milliseconds first, I think. So hold on. The right edge is t minus 0. The left edge is t minus 5,000 milliseconds. That's what's going on there. So I really need to get my time here. So we're going to say the left time is going to be my I think I want something called the right time is what I want. And I'm going to make that equal to 0. So my right time, my left time is equal to the right time minus that. Then at some point in time, I'm going to say right time is equal to my left time before I'm done with this. Now that I have my two times, I've got to convert those into pixels, right? So call this left X, or just maybe left, left line left. And I need a line right, like that. Line left is equal to, let's get this right here. It's going to be my left time. So to convert a time into pixels, I need to divide by the time and multiply by my graph width. So it's equal to left time times graph width divided by time span. I think that's right. And graph width divided by time span is like my converter. So I think I want to declare something for it right here. This is going to be my time to px pixel factor, like that. All right, so, but that's going to start from the left side, and I want it to be from the right side, so I need it to be right edge minus that, I think. Which means my line right is equal to my right time minus that. Now, is that right? Am I getting these mixed up? I think I might have them backwards. It may not matter because drawing from one side to the other may not, it may not matter if they're backwards or not. The left side is the left time. The left time and the right time is there, the right edge. I think it's correct. All right, so next I want to do a context dot move to I think I want to do this. Hey, look, if I is equal to 0, then we're going to say context.move to. Otherwise, we're going to just do a line to call on it. And now the y here, got to calculate the y. I said nice flat 30 frames per second value. That's not bad so far. We'll see, because I'm not doing anything else. Here, let's do something. You should see a dip. Let's do it for everybody. There we go. Okay. Let's go back into what we're drawing, what we're doing here. The y we need to calculate here. So if context there, then we want to next say context.line to. Oh, but we're going to kind of be drawing backwards. So I want to actually move to line right here, I think. Go to line right, and then from move to line right, and then go to line left. Yeah, arguably we're executing this line of this expression more than we need to, because we could just say that line right is equal to line left, and we may not need right time at all. You know, we need right time here. Something's wrong here. Something's wrong with my logic. Time between frames. Right time is equal to left time. Wait, it might be okay. So what's happening is right time is incrementally moving to the left is what's happening. All right, we're gonna try it. We're gonna see if that works. We just gotta get the Y in the right spot. The Y is essentially 1,000 divided by, it's math.round of 1,000 divided by this entry. Well, not quite. That's not quite right. It's here. It's this kind of thing is what this is right here. So it goes like time this frame. We want to clamp it. And then we want to do that. I was going to track how much time we've graphed, but I think we don't need to. Oh, wait, we do, because we need to see if if line left is ever less than, if line left is less than this dot left, then we're going to break. There's a chance this works. Then we're going to call stroke. We don't need the move to or the line to. We call stroke. There's a chance this works. There's a chance it works. Let's see. So when you've written code, we're writing code for like what seems like about a half hour, 40 minutes. Never, yeah, the longer we write code, the greater the chances are that please add song request. I don't know if we'll be able to do that. What's it look like? That doesn't look good. Oh, hold on. This is time between frames. That's not the same thing. I want it to be 1,000 divided by that, I think. Let's try refreshing that, see if that little fix is going to help us. Okay. Seems like we're way off. Is that because we just only have so much data? That's 150 data points. What's going on here? I've got 5,000 seconds. We're like kind of close, right? We're seeing kind of things kind of move kind of up and down. Let's throw some stress at it. Let's initialize player data. Okay. The 30 is not going down, but it's clearly not. Also, where there's this crazy data density. Oh, wow. The data looks way denser. There's also evidence that we're drawing multiple times over it without erasing it. Are those lines the FPS history? Yeah. That's what I'm trying to get here. They're in the wrong place, and but their height looks kind of good. I think it's reflective of what's happening. Don't we want 60? Sure. 60 would be great. The problem is I'm struggling to get sometimes 10. So part of what I'm doing here is I'm trying to get a frame rate meter with history so that we can make changes and see what the impact is. One of the things I'm trying to do. But I think I'm clearly not graphing the data correctly, and I think what I need to do is I think I need a break from this. I need to kind of think about what's going on and come back. But it looks like it's drawing multiple times. Definitely seems to be that. Another new question. Have you considered adding extra compression to the original sprites? I don't think that's the problem. The problem isn't loading the sprites up. So I'm already throwing PNG gauntlet at them to make them as tiny as possible. Might just be that they're too fat and this adds extra red. No, we've actually seen one of the big problems is doing setting the filter on the context for hue shifting. It's supposed to be fast, but we saw it was causing problems. And so what I want to do is I'm creating metrics, right? I'm doing this right here so that we can see what, get a more visual sense of what's happening. But I think what I'm going to do is take a break, get some lunch, and end the show for today. And we'll pick this up tomorrow. Or not tomorrow. Tomorrow's Saturday, isn't it? I'm not sure. We'll pick this up maybe Tuesday. And I'm not sure what's going to happen. You're doing art. Imagine. Tomorrow's not show day. Cool. All right, let me go. What kind of art do you do, Pudding? Why'd you say ha-ha, Surly Dev? I was thinking of a Saturday stream then. Yeah, I don't think it's going to happen. Let me ask my wife what she thinks about a Saturday stream.
We are already streaming on Saturdays. We're already doing a show.
Yeah, so I'm not going to do a Saturday stream.
No.
Screw you guys, because you know what? I love my family and I don't love you. That's the truth of it. None. I'm learning because I want to up my game before my first coding stream. Oh, okay, cool. Nice. Surly's ha 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 like that. Let's do a raid. Shall we? Let's get that set up. Send you over to, should we send you to? Send you to Chef Brent. We haven't done a raid over there in a while. Let's get that going. thanks so much for joining us. We will see you next Tuesday. And like I said, follow us out on Wait for the Clip. I don't care about my phone. I don't have one, says Pudding. Go out to Dragon Humpers. Give us a follow if you're not following already. And we will see you maybe over the weekend on that show. And if not, next Tuesday. Thanks, everybody.
All right.